When there's only one variable in an equation, your answer will be a number. Okay? Or your answer might be that there's no solution. But if the equation has a solution and there's only one variable in it, those answers will be numbers. Those solutions will be numbers. But the question on the right, the problem on the right here, has more than one variable in it. And so instead of that equation describing a value that the variable x has, instead what it describes is a relationship between the value of one variable, x, and the value of another variable, y. Has anybody seen an equation that looks like this before? This was inspired by an actual relationship between two quantities. Does it look familiar? So both of you are right in one way. So Jacob, what did you say? Slope-intercept. Yeah, so you both said y equals mx plus b, slope-intercept. Right, so it has that flavor to it. When we get forward into Module 4, we're going to talk in more depth about slope-intercept equations of lines. That is, in fact, a type of an equation of a line that we have here. So if we were to graph this relationship, we would see that there's a relationship between x and y, which looks like a straight line on a graph. The real context, the real application from which I drew this equation is the conversion between Celsius and Fahrenheit measurements of temperature. These are two different ways to measure temperature. If x is the temperature outside in Celsius, then y is the temperature outside in Fahrenheit. This is the equation that accomplishes that conversion, one to another. I think, actually, this equation has an extra set of parentheses compared to the real thing. So take that with a grain of salt. It was inspired by, but is not exactly the conversion for Celsius and Fahrenheit temperature. But the point is, when we solve that equation and we get x equals, that solution is going to have x equals some expression that still has y's in it. So our answer is not going to be a number for x, but it's going to be another expression that tells us how x relates to y in a different way that the original equation tells us how y relates to x. But the answer to the problem on the left is going to be x equals some number. So that's a useful check on your own work when you're solving an equation, that if your equation has more than one variable in it, odds are its solution will also have more than one variable floating around it. It won't just be x equals a number. But if your equation only has one variable in it, then the answers are likely to be numbers. Very, very, very likely, 99 point whatever.